In question 3, we have a graph of force against time for a ball. In part A1, we're asked to find the maximum force applied to the ball. This is just the peak of the graph at 48 newtons. Then we're asked for the time the boot is in contact with the ball. This is just where the line goes back to the x-axis at 0.25 seconds. For part 2, we're asked to explain how we'd use the graph to find the impulse is 6.5 newton seconds. Well, impulse is force times time, and this is the area under the graph. We could find that by counting squares. For B, part 1, we're asked to find the maximum acceleration given the ball has a mass of 0.60 kilograms. Acceleration is force over mass, which is 48 newtons for the maximum acceleration over a mass of 0.60, giving an acceleration of 80 meters per second squared. For the final speed of the ball, we know that impulse is equal to change in momentum, which is mass times change in velocity. So change in velocity is equal to impulse over mass, which is 6.5 over 0.6, which gives a change in velocity of 10.8 meters per second, or 11 meters per second. For part C, we're told the ball hits the wall at 11 meters per second and rebounds along the initial path at 6 meters per second, with the impact lasting for 0.18 seconds. We're asked to find the mean force exerted by the ball on the wall. Well, impulse, force times time, is equal to mass times change in velocity. So the force is equal to mass times change in velocity over time, which is mass times v2 minus v1 over time, which is 0.6 kilograms times minus 6 meters per second minus 11 meters per second over a time of 0.18 seconds, and this comes out at 57 newtons.